Okay, having left off with this one, we started out with a 150 kilometer vector, 20 degrees east of north. Okay, so it was kind of like this. So we went east, or sorry, we went north, and then we went 20 degrees east of north. Okay, so this will be our x, this will be our y, and this was 150 kilometers. Okay, and then we had the 265 at 45 degrees south of east. So there's east, okay? 45 degrees south of east would look something like that. Okay, and this will be our x, and this will be our y. Okay, and our resultant is going to go this way. And it'll have a triangle that looks like that. Okay, where do you arrive with that? So this will be our overall displacement here. All right, and I think we had even gotten to doing the x's and y's on Friday, if I recall. Okay, so if we're looking at this one here, we got to calculate our black x. Okay, so black x is the opposite side to our 20-degree angle. So that'll be the sine of 20, okay, times 150 kilometers. So sine of 20 times 150. All right, so 51.3 is what black x is. 51.3 kilometers east, and obviously I'm going to keep all those decimals for later. Okay, to get black y, y is the adjacent side, so we'll go cos of 20 degrees times 150. And it's 140.95 kilometers, and that one's north. Okay, and then we've got to do the same thing for the red triangle over here. Okay, but luckily it's going to save us a bit of time because it's a 45-degree angle and the two sides are equal. Okay, so x is the adjacent side, cos of 45 times 265. Okay, so 187.38, and y is the same thing, right? So 187.38 kilometers. That one's east, okay, and y is 187.38 kilometers south. Okay, so now that we know all of those, now we can calculate our resultants y. We went a little bit north and a little bit south, so we would have to subtract the y's. Okay, but both of them go east, so we can add the two x's. Okay, so to get green x, okay, so for green x, I'm going to take the 51.3 and add it to that one. Okay, so we're looking at 238.7 meters. Obviously, I'll keep all those decimals. Okay, and then for y, I'm going to subtract them because they were opposite, so I'm going to take the bigger one and subtract the smaller one. So y is 46.4 meters. Okay, and so this one is south and that one is east. Okay, questions so far? Now that we've got those, can I calculate my overall displacement? Okay, what do I do to do that? How do I get D? Pythagorean theorem. Okay. So to get my overall D, that's going to be the square root of 238 squared plus 46 squared. Okay, obviously with all the decimals. Okay, so we're looking at 243.16 kilometers. Okay, we also need to find theta. Okay, theta is right here. Opposite is the 238 and adjacent is the 464. So that'll be 10 to the minus 1 of 238 over 46. So we're looking at 79 degrees, because I think we only have two significant figures here. Yeah, 79 degrees. And for me, what direction is that going to be? East of south. Okay, and the question didn't want the displacement. Yeah, sorry, they did want the displacement, which we already have. Okay, it could be 11 south of east or 79 east of south. Okay, the whole trip takes 12 hours. What's the velocity? All right, so I've got to take my total displacement, this number here, and divide it by the time, 12 hours. Okay, so 243.16 divided by 12. All right, so we're looking at 20 kilometers per hour at 79 degrees east of south, or at 11 degrees south of east. Okay, that is about as involved as they ever get. Okay, there's a ton of calculating, a ton of trig in one like that. Okay, questions on that one? Did I lose anybody anywhere? I know I went kind of fast, but we've done like 3/4 of it on Friday already. Okay, so I'm going to want you guys to do from the digital workbook here. Okay, so we just did 13. So I want you guys to do 14, 15, and 6. Okay, so for 14, we got a plane that flies 620 kilometers per hour at 40 degrees west of south. Does it matter that it's a velocity and not a displacement? Okay, we draw it exactly the same as before. All right, so we got 40 degrees west of south. So I'm going to draw my reference line south. And like so, go 40 degrees west of that. That might not be 40, but we'll have to do. Okay. And that's not nearly long enough. And then we're going to have 70 to 75 degrees east of north, okay, for our other one. So here's my reference line that's north, okay, and it's 75 degrees east of north. So it's like that. Something like that, I think. Okay. So I'll have a line going there. This will be our y, this will be our x. That's 500, and this angle here is 75 degrees. So it's another one of those busy diagrams. So if you're wanting to solve this with separate triangles, absolutely okay to do it that way. It'll be y, it'll be x, that'll be theta, and this will be our average velocity this time because it's a velocity question. All right, we'll give you a few more minutes and then I'll start on the math of it here. Okay, so for this one here, okay, for our first vector, okay, if we're looking for x, x is the opposite side to my 40-degree angle. So we're going to have sine of 40 degrees times our 620 kilometers per hour. So sine of 40 times 620. All right, so we're looking at 398.5 kilometers per hour, and that is, west, not south, west. Okay, then we're looking for y. Y is the adjacent side to the 40-degree angle, so that'll be cos of 40 times 620. Okay, so we're looking at 474.9 kilometers per hour, and that one is south. Okay, and then we have to do the same thing with the red triangle. Okay, red x is also our opposite side to the 75, so sine of 75 times 500 kilometers per hour. Okay, so that's 482.96 kilometers per hour east. Okay, so we did draw that one right. It does go past, right? This x, the black x is smaller than red x. Okay, and then for y, it's the adjacent side, so cos of 75 degrees times 500. So we're looking at 129.4 kilometers per hour north. Okay, so now that we've got those, now we can find our resultants x and y. Okay, so our resultant, or blue x, is going to be the 487.96 east minus the 398.5 west. Okay, so we'll have 487 minus the 398. Obviously with all the decimals in place. Sorry, not 487, 482, sorry. Can't read my own writing. Didn't I tell you guys? I warned you guys about that too, didn't I? Should practice what I preach. Okay. Minus that one. And I forgot to put the minus in there. That's not where I want it. Okay, so we're looking at 84.4 on that one. So 84.4 kilometers per hour, and that's going to be east. Okay, and then our y's, one goes north, one goes south. Okay, so we'll take the south and subtract the north. Right, so that'll be our 474 minus our 129. Okay, so we're looking at 345.5 kilometers per hour, and that is going to be south. Okay, so now that we've got those, now we can get our overall average velocity using Pythagorean theorem. Okay, so that'll be the 345 squared. Wow, that's terrible. Sorry, let me try that again. 345 squared minus the 84 squared. Not minus, plus. Sorry, guys. Squared plus 4 squared. Okay, so we got 355.7 kilometers per hour as the magnitude of our resultants. Okay, and then we need to find our angle. Okay, the way I drew that, y is the opposite side, so we'll have 10 to the minus 1 of the 345. 345 over the 84 to get us our angle. Okay, so we're looking at 76 degrees on that one. And that, for me, is going to be south of east. Okay, so now we've got the average velocity. That was part A. Okay, part B, what's the displacement if the plane flew for 7.5 hours? Well, displacement is average velocity times time. So all I have to do is take this 355. Okay, and multiply it by 7.5 hours. And that will get me my displacement. Okay, so we're looking at, how many significant figures do we have here? 2. Okay, so we are looking at 2.7 times 10 to the 3 meters at 76 degrees south of east, or 14 degrees east of south. I put meters, yes, should be kilometers, sorry. Okay, is that one pretty long?
Yeah.
Yeah, it is. Not as long as the last one. The Indiana Jones one is longer because it has many vectors. But not many of them are angled. All right, we'll put those back up and you guys can keep going here. Oh, sorry, it's the football player one that doesn't have as many angles. Obviously, I would never give you ones like that on a test or a quiz because they take way too long. Okay, so for 15, first we have 10.5 meters at 25 degrees south of west. Okay, so we're going to start here with going due west. And we're going to go 25 degrees south of that, so something like that. Okay, that'll be 25 degrees. Okay, X, Y, and this will be 10.5 meters. Okay, and then they're going to go 15 meters at 20 degrees west of south. So I'm going to draw a reference line that's due south. Okay, and it's going to be a bit longer. Right, we're going to go 15 degrees west of south. So sorry, 20 degrees west of south. So 20 degrees, and it's 15 meters long. So this will be X, this will be Y. And then lastly, we have 8 meters due south. Okay, so that means our resultant is going to look like this. So that's what our diagram should look like. Anybody ready for the math already? Okay, so we'll start out with our black rectangle. Okay, black X is the adjacent side. So we'll be using the cos of 25 degrees, not 20. 25 degrees, okay, times 10.5 meters. Cos of 25 times 10.5. So we're looking at 9.5 there. Meters west. Okay, our y component's the opposite side, so we're going sine of 25 times 10.5 meters. And so we're looking at 4.4 meters on that one. And that's south. Okay, are we okay with the black triangle? For a red triangle, okay, red X is our opposite side, so we'll be going sine of 20 degrees times 15 meters. Okay, so that's 5.1 meters. And that one is also west. Okay, and then our y component is the adjacent side, so we'll be going cos of 25 times 15 meters. 25, 20. Holy smoke, guys. Having a tough day here. 15. 20 times 15. Okay, 14.1 meters, and that one is south. And then obviously the blue one has no x component, okay, and its y component is 8.0 meters south. Okay, everybody good there? All right, good news is everything goes south and west, so we can add everything. Okay, we don't have anything that backtracks on itself here. Okay, so when I'm finding my resultants x, I simply add the two x components together. 9.5 and 5.1 will give me green x. All right, so green x will be 5.1 plus the 9.5. All right, so we got 14.6 for our x component, and then our y components, there's 3 of them on this one. They're all south, so I can simply go 8 plus the 14.0, that one there, plus the other y component, which was the 4.4. All right, so we add those ones together there. All right, and we're looking at a y component of 26.5. That way. All right, so now we can calculate our overall displacement with Pythagorean theorem, same as we always do. So we'll have our 14.6 squared plus our 26.5 squared. All right, so we're looking at 30.3 meters. Okay, and then we need to find our angle. All right, the way I drew the triangle, x will be the opposite side, so I'll have tan to the -1 of 14.6 divided by 26.5. All right, so we're looking at an angle there of 28.9 degrees. And for me, that's going to be west of south. Okay, and is that all they wanted? No. Okay, so we've got our overall here. Okay, we only have 2 significant digits, so it's 30 and 29 degrees west of south. And then if we wanted to find the overall speed, okay, well, is that a trick? It is, yeah. Okay, and guys, that is honestly the kind of trick I would play, because that's who I am. Okay, distance and speed are scalar, correct? All right, so does that actually make it easier? Yeah, okay, all I have to do is go 10.5 plus 15 plus 8, and I've got the total distance, and I divide that by 35 seconds. Okay, that's just one of those things that's testing. Do you remember that distance is scalar, that speed is scalar, and speed is distance over time, and that you require none of everything you've done here? Okay, that's the kind of thing you always have to be on the ball for. Okay, so all we would do was add those distances together. So 8 plus 15 plus 10.5. There's our total distance traveled divided by 35 seconds. Okay, and our speed is 0.96 meters per second. All right, how many people have started the Indiana Jones one? The distance was, you know what, I don't know that I cut. It was 33.5. Okay, I want you guys to take about 3 or 4 minute break here, because you've been doing this non-stop since class started. So take a 3 or 4 minute break, and then we'll look at the last one. Okay, so I don't know if you guys have seen Indiana Jones and the Raiders of the Lost Ark, but in that one, the little idol. We're actually going to look at that from a work energy perspective in Unit 2. We'll watch that video clip and that kind of stuff. Okay, so he sprints 25 meters at 30 degrees west of north, Okay, first off, to avoid the large rock, okay, that is rolling towards him. Okay, so we got west of north, so here's my reference line, north. Okay, and we're going 30 degrees west of that. Okay, and that's 25 meters long. Okay, and here's X, here's Y. All right, then we've got 46 meters at 18 degrees south of west. So there's west, 18 degrees south of west. That's not nearly long enough. Still not. Come on. I'll move the X myself. Okay, so 46 meters needs to be a lot longer than that other one. Scale's going to be important. And the angle changed halfway through. All right, so that's going to be 18 degrees south of west. Here's X, here's Y. This one's 46 meters. Then we've got 10 meters due south. And then we've got 18 meters, 40 degrees east of north. Okay, so we gotta go back north, and we're gonna go 40 degrees east of that, so somewhere in there probably. There was 18 meters, it's gotta be longer than that. We'll get it right here. Scale's important, right? So okay, that'll be X, and that'll be Y. So our overall resultants is going to look like this. Okay, that's what it should look like.